Okay, students. Now, so far in the last two video, we have discussed about unit and how by using that unit we can express a measurement with some numerical part and unit, and what are the systems of units we are adopted, and the some of the practical units that we are using in our day-to-day life, that also we have discussed. Now, as this chapter consists of unit and dimension, if you remember, it is the unit and dimension chapter. So we have discussed, we got the information about unit part. Next part is the dimension. So that's why I can make it as a subtitle as a dimensional analysis. Now we will know about dimension and we will analyze that by using what this dimension, what it says. Now, before we go to this dimension, let me cite an example. When you pass your 9th class, then the only option for you to admit in 10th class, that is your one way of proceeding to higher class. Means, I will say that in our day-to-day language, in our day-to-day discussion, I will say that you have only one dimension. Means, after 9, you have only one dimension, means you will go to 10th. But after passing that 10th, here you have more than one dimension. For that, you can join in +2, or you can go for ITI or some other. So means your dimension is open. So what this means? After passing this 9, you have one dimension, that is to the 10th. Means you are only fit for 10th, admission in 10th. But after 10th, you have two dimensions, suppose I will say. You can go for +2 or you can go for ITI. So you can fit for the two dimensions. In the two cases, means I can say you are fit for these two dimensions. So that means, what this dimension, are you getting that dimension means? From here we know that, or you can say that dimension means you are a physical quantity. Imagine that you are a physical quantity by which the laws of physics can be explained, that is called physical quantity, and you are the physical quantity, and to fit that physical quantity means to make you more complete, or you can say to make us complete, to make me or a 10th class student to make him complete, or to expose. He has two dimensions. He has two dimensions. Means he can fit for that two. Clear? So accordingly that a dimension means what we can say, dimensions of a derived unit. Generally, the dimensions of a derived unit. The derived unit comes from a derived physical quantity, because the fundamental units does not depend on others. The derived unit depends on the fundamental. So we are getting the dimensions of a derived unit. Means for you to make you more exposed to the surrounding or exposed to the society, you are going for that higher classes. Means you are a person and you are complete. As a human being, you are a complete one. But to expose your educational knowledge or to know more about education or the studies, you are going for higher classes. That means to make you complete things, that means here you are a physical quantity, but in that case, when you go for your education part, means you become say derived. So dimension of a derived unit are the powers to which the fundamental units the fundamental units, like what the units of what? Of what? Mass, length, time, etc. The fundamental units of mass. Mass is a fundamental physical quantity. Its unit is fundamental unit. Length is a fundamental. Time is a fundamental, etc. There are 7 and 2 derived. Supplementary. There are 7 fundamental and 2 supplementary. So the fundamental units of mass, length, time, etc. must be raised. Must be raised. It must be raised to represent that unit. To represent that unit. Is that clear? The derived unit, to represent the derived unit, what the powers of fundamental units to be raised, that to represent that derived unit are called, the powers are called the dimensions. The powers are called as the dimensions. Then means what? If I write this in a dimension, then if you know the definition of dimension, then the dimension, there are 3 definitions are coming here. Dimensions, dimensional formula, dimensional equation. All are same. Once you know the dimensions, then all the things are same. So first I will define one by one. So this is the dimension. Let me write the definition, then we will go for examples. Then the next one is the dimensional formula. So what is the dimension? Dimensional formula. So dimension means is their powers. If you go for example, then it will be clear. Dimensional formula is an expression which shows how and which of the fundamental units, how and which of the fundamental units, how and which of the fundamental units, how means what power and which fundamental units, either mass, length, time, current, temperature, like that. Okay, so how and which of the fundamental units are required to represent the unit, to represent the unit of a physical quantity, right? Maybe a derived physical quantity. So if you know the powers, then we can write that by the dimensional formula, right? How and which, what are the powers to be raised, and which of the fundamental units powers should be raised, that writing in a expression, that is called dimensional formula. Next is the dimensional equation. So what is this dimensional equation? Dimensional equation means it must be equating. Equation means it should be an equal sign, equating. So dimensional equation is the equation obtained by equating the physical quantity with its equating the physical quantity with its dimensional formula. With its dimensional formula. Got it? With its dimensional formula. Clear? So this is the three definitions in our dimensional analysis. Means as a whole, I will say that dimension are to represent that in powers of which of the fundamental units to be raised, so that you will get that derived unit of the derived physical quantity. Then next one, the dimensional formula means expressing how and which of the fundamental units are to be raised. Dimensional equation means equating that. That is the dimensional equation. Clear? Clear? After knowing that, let me go for an example. Let me erase this one. Okay? Are you getting this one? Then let me go for an example. Then I will show that how we can express that and what the difference in dimensional formula, and the dimensional equation. Clear? So now let me give an example. Right? So let us take a simple example like here. Area. Take an example like area. Area is a physical quantity. Area is a physical quantity, and it is a derived physical quantity, because area is not coming under here 7 basic physical quantity, fundamental physical quantity, and 2 supplementary physical quantities in SI. So area is a derived, right? So this area means it should be a formula is what? Your length into breadth. Length into breadth. Clear? That you already know that area is equal to length into breadth. Clear? Now the next part is that when you write this area is equal to length into breadth, when you do that means you can say that length means one is the dimension, right? For length means you are measuring the length, and the other one is again a length. So if you multiply these two lengths, then you will get the area. Then when I say that, means you can say that dimension, if I ask you what is the dimension of this area, so you will say that the dimension of area is two dimension in length. 2 dimension in length. Breadth is also a length. So 2 dimension in length means to get this area, length should be multiplied 2 times. 2 times you measure the length. One is the length, and the breadth means 2 times you are measuring the length, and you are raising that 2 times. So this is the dimension, means you will say that 2 dimensions in length. So you will write 2 dimensions in length. So that is the expressing the length, right? Dimensions in length. Clear? 2 dimensions in length. When you say that, what is the dimension formula? Means for length we are representing that dimensional formula means it should be length, means for length you are measuring length 2 times. So I will write this L2, L1 into L1, L1 into L1, L2 within a square bracket. Then the dimension is written in a square bracket. Clear? The dimension with powers. Okay. They are in a square bracket, are denoted by square bracket. So this is the dimensional formula. This is the dimensional formula. Which of the fundamental unit? Length is a fundamental physical quantity. Its unit should be raised how many times? 2 times with the power. So by writing like this is called a dimensional formula. Suppose I will say, I will tell you or ask you write the dimensional equation. So to write the dimensional equation, I will write this as equation means I will write area is equal to L square, equating that. This is called as the dimensional equation. Means equating the dimensional formula with the physical quantity, that is called dimensional equation. Clear? Or all of you got that? How we will differentiate between the dimensional formula and dimensional equation. Clear? Now next we go for the dimension of the physical quantity. Before we go to that, find the sum of the dimension of some of the physical quantities. Before I go for the dimension of, to find the dimension of different physical quantities, derived physical quantities, now we will go for, first we will go for the how to represent, how to write the dimension of the fundamental physical quantities or fundamental physical units dimension. Okay, so the dimensions, first I will find the dimension. I will write dimensions of, that is common for all, dimensions of fundamental physical or dimensions of fundamental physical quantities. First I will find the dimensions of fundamental physical units or quantities. First we will find how to write the dimensions of fundamental physical quantities. So the fundamental physical quantities are, let me write the 7 fundamental quantities like this: mass, length, then time, then temperature, fourth one is the temperature, and the electric current, and luminous intensity, and the 7th one is the mode. So these are the 7 fundamental physical quantities, okay, or base physical quantities. And the dimension of these 7 fundamental physical quantities are like, for mass, it should be written in capital letter M. With its power, 1 is mass is 1 time, so I will write M1 with a square bracket. So this is the writing the dimension of the fundamental physical quantity. For length, we will take this as capital L with 1 times of length. For time, capital T with 1 time, T1. Clear? Then for temperature, it should be K Kelvin, so 1 time, right? For electric current, it is a ampere, so capital A with 1 ampere. Luminous intensity, candela, so that is written CD with 1, so this is CD. And mole, I can write this as MOL, mole with 1 power 1, writing 1 or no, without writing this one also, it different with 1, so I can write MOL 1. Okay, so means the units are like that. In SI you can say that mass is in kg, in SI system it is kg, and for length it is meter, for time it is second, SEC or simply S, and temperature, that is simply Kelvin, and for electric current it should be ampere, and for luminous intensity it should be candela, and for mole it is simply, it is the, or mole you can say that is the amount of substance. In terms of physical quantity you can say that amount of substance, for mole it was, and that unit is a mole. Okay, so these are the 7 fundamental physical quantities and their dimension. So if there is a length, means we will take this as a capital L. If there is a luminous candela, then we will say luminous intensity. The derived unit depends on luminous intensity, means I will take this as a CD power 1 to write the dimension or the dimensional formula. By using this, now we will go for the dimensions of some of the derived physical quantities. Now we will go for the dimension of some of the derived physical quantities. So now, after getting this one, let me find one by one. Already I have done this area part. So area, now let me go for that. simplest one is the, again I will go for area. So let me write here the physical quantity for which I will find the physical quantity, then for which I will find the dimensional formula, then the relation on which it depends, which one depends? This physical quantity, the derived physical quantity depends on which of the physical quantities. Then the next one is the dimensional formula. Means you know the dimensional formula, then you know the dimension and the dimensional equation. Then I will go for the SI unit and the SI unit. Right? So let me find first is the derived unit is area. So as you know, this area is, I can write this area in the formula on which it depends length and breadth. Or you can say for any area it is the multiplication of two lengths. It is the multiplication of two lengths or square of two lengths. So area means on which it depends length and breadth. Clear? For area it depends on length and breadth. So length is multiplied by 2 times. So to get the dimension formula, we take this as 1 is for length L1. For breadth also, this is also L1. So we multiply this, we will get L2 with the square bracket. So this is the dimensional formula. And its SI unit is, what is the unit of this length? It is meter. So its SI unit is meter square, m to the power 2. So this is the method of writing the dimensional formula. Clear? Then if I ask you, write the dimension, what is the dimension of this area? You will say that 2 dimension in area. Suppose I ask you, what is the dimension of this area? It should be 2 dimensions of area. It should be 2 dimensions of area. Suppose I will ask you, write the dimensional equation. So we write the equation as area, it should be equal. So you should put an equal symbol. So area equal to this physical quantity is equal to which dimensional formula? That is L2. So I will say that this is the dimensional equation. So that is the difference between the different dimensional formula, right? And next is the another physical quantity. Let me go for the volume. So as you know, volume is the multiplication of 3 lengths, right? So one is the, so I will write the formula for this volume: length, breadth into height. What is length, breadth and height? So we are measuring the 3 lengths. Clear? We are measuring the 3 lengths. So 3 lengths means L1, and for breadth again the length L1, and for height it is again L1. So to multiply this L1 into L1 into L1, we will get this is equal to L to the power 3. Clear? So this is the dimensional formula. If you write the SI unit, it should be meter cube, or SI unit, it is meter to the power 3 because L cube. So this is a meter to the power 3. Clear? So this is the dimensional formula volume, right? Then I will go for the density. Number 3, suppose I will go for density. What is the density? So what formula it depends? Write the formula relation on which it depends. Density is equal to mass by volume. Mass by volume. So mass by volume means this, when you do the relation here, these two are simplest one, but here when you are solving this one, you should do the relation to make the relation to the fundamental units. Here you see the density depends on mass and volume. As you know, how much heavier, right? Density means what is the mass of the substance in a unit volume. In this volume, what is the mass? That is called as the density, right? A body is having high density means more is the mass in a smaller volume. So that is called as a density. So when you say the density part, mass by volume, means Here, it does not depend on the two factors which are not the fundamental units, or fundamental physical quantities. So, to make that fundamental, means I can write this as mass, and the volume is, yours should be length, breadth, and height. That is the formula for volume or multiplication of 2, 3 lengths. So, this, now the density, when you write the dimension formula, you should make like this steps. So now to know the density, you should depend on mass. You should depend on mass, and you should measure the mass, and you should measure its volume, and the volume can be measured by using these fundamental physical quantities or fundamental physical units. Clear? So now it is all involve the fundamental units. But this equation, mass is only the fundamental physical quantity, but volume is not fundamental. It is derived. So the derived should be in fundamental. So now you put here. So this equals to write the dimension formula m1 here for mass m1 divided by what is volume L1 that is L So I can write this is equal to simply written as we are not writing like this the dimension formula M1 L take the L to the power minus 3 that should be in a line and it should be in a square bracket M1 L minus 3. So that is the density. So if I ask you the dimensional equation means you will write density is equal to this one. And this is the dimensional formula. So if I ask you what is the dimension of density means what you will say? The density will fit, right? The density will fit to this dimension. Means 1 dimension in mass minus 3 dimension in length. 1 dimension in mass minus 3 dimension in length. You will say like that. Dimension means, right? And its SI unit is what? For mass, SI unit is what? kg to the power 1. For mass is kg1. For length, meter to the power minus 3. Right? So this is the SI unit for density. Clear? Or this is also called as the mass density. Clear? Then we will go for specific gravity. Another physical quantity is like the specific gravity. The fourth one is the specific gravity. What is specific gravity? I don't know about the specific gravity. For the time being, you remember that specific gravity means how much heavier is the substance compared to equal volume of water. Compared to water, how much heavier the substance you are comparing. Means that is the specific gravity. And it is the formula for this one is the density of the body. The formula for this one is the density of the body. Density of the body divided by density of water at 4 degrees centigrade. That is the formula. Means for the physical quantity, then you remember this physical quantity. Now for the time being, you have to remember this formula. But when you go for more and more studies, you will know about this physical quantity. Then it is very easy for you to remember this formula. Clear? For the time being, it is very, but it is like a little bit of difficulty for you to remember this formula because you don't know about the specific gravity, or suppose you know, then it's well and good. If you don't know, then don't bother about this one. You will know that in later. So specific gravity means here how much heavier is the substance with compared to the water, with both are of same volume. Clear? So this specific gravity means density of the body by density of water. So already you know the density of a substance and density of a substance. So this is density by density. So then again you will find the mass of the body divided by volume of the body. Mass of water divided by mass of volume of water. If you divide all these things. So it is density by density. Means that will obviously if you put the dimension, then density means what is the dimension of density? That is m1 L minus 3 for a body. That is the same dimension. So I will write this square bracket divided by what is the density of water? Same formula m1 L minus V. That is the density of the water. Means if you are changing the substance, the physical quantity is same, so its dimension is same. So it cancels. So what will you get? You will get F0, H0. So you can put also T with 0 also. So you can write this with the what? Dimensional formula. Then what is this SI unit? There is no, it does not depend on mass and time. Means that the powers are 0, so there is no unit. So it has specific gravity is a physical quantity, there is no dimension and no unit. It has no dimension and no unit. Here, again we will go for the dimension of speed. Next is the dimension of speed. So the fifth one is the dimension of speed. So when you say about speed, what is the speed means? What is the distance covered for unit time? Or you know about speed? My speed is 5 km per hour. Means I am moving 5 km in 1 hour. That is called as a speed. So speed, the formula is distance. I will write the formula. How much distance covered divided by time. So now you see this speed depends on the two fundamental physical quantities. So no need to make it more simplified because both are the distance is what? Is a length. Distance is also a length. So length, breadth, height, distance all are the what? Length. So distance is L1, time is T1. So we write this as a L1 T minus 1. So I will write this as a dimension formula. L1, the dimension of speed is 1 in length minus 1 in time. Then what is the SI unit? For length it is meter 1. For time it is second minus 1. This is the what? SI unit. Next is we will go for the velocity. Now we go for the velocity. So you know about speed and velocity. Speed, you have, I think you have read that is a vega. In Odia that is called vega, and in velocity I think that is called as a pariveg. Right? Vega and pariveg. So what is this velocity? Velocity, when you calculate this velocity, it is not the distance, it is actually called as the displacement. Means for the time being, when we will read this letter, we will know about what is the difference between distance and displacement. We will know it later. But for this time being, you remember this displacement by time means it involves, when you calculate the speed, it does not involve any direction. But when you calculate the velocity, it involves the direction. So if the direction comes, distance changes to displacement by time. That is the formula. So displacement is again a distance. You are measuring the displacement means it is again a length. You are measuring a length. So L1, T1. So L1, T minus 1, same thing. So now means what? You are getting here that speed and velocity are two different physical quantity, but both have same dimension. That is one of the conclusion we got from your dimensional analysis. Means two different physical quantities, have same dimensions. Two different physical quantities may have same dimensions. Two different physical quantities may have the same dimension. That already you know from this derivation. Clear? So next is the another type of physical quantity here. Let's go for the another physical quantity, that is your velocity gradient. So now go for the velocity gradient. Velocity gradient. What this velocity gradient means? You have an idea, otherwise you know that. For the time being you know that. I am giving some little bit of idea about the physical quantity, but in the later course of time, you will know more and more about this physical quantity. For the time being, to recall or to remember that, I am only discussing this. Velocity gradient means, always remember, any gradient means change in the first physical quantity with respect to distance. If I change the distance, how much is the velocity changes? right? For the 5 kilometer, I am moving with a velocity of 5 meter per second. Because your unit is meter per second in SI, we are discussing about SI unit because in this total course of time, always we are concerned with SI system of unit. We are not using any other. CGS is not we are using. But if you know that, you can also take the CGS unit. But I am always concerned with your SI unit. So the velocity gradient means what? How much? Suppose I am moving with a velocity of 5 meter per second for the 10 kilometer. Then after the 10 kilometer, after the distance 10 kilometer, I am moving with 10 kilometer per hour. Means for this 10 kilometer hour, I am moving for 7 kilometer. With a speed of 10 kilometer hour, I am moving 7 kilometer. First 5. It is 5 km per hour. Next 7, it is 10 km per hour. Next 8 km, I am moving with 3 km per hour. So that is called velocity gradient. How the velocity changes with respect to distance. Means it should be the formula should be velocity divided by distance. With respect to distance, which one? What is the change in velocity with respect to distance, right? So this is the distance covered divided by or change in, or you can say that change in velocity with the distance. So you can write also this is the change in velocity by distance. Change in velocity means that is only velocity. So as you know, already know the dimension of velocity. So no need to go for velocity. If you don't know, if I ask suddenly what is velocity gradient? So it is velocity by distance. Change in velocity means that is also velocity. Clear? So that is the dimension of change in velocity. What is the change in velocity? Is again a velocity. Change in velocity means 5 meter per second minus 7 meter per second means this is minus 2 meter per second. The result is also a velocity. So not bother about change in velocity means it is only the velocity. So if you don't know what is the dimension of velocity, then you go for simplify this formula. So now we go for velocity means it is the displacement on what fundamental? Displacement by time, that is velocity. And distance, that is this distance. Now this is the all depends on this velocity gradient has all the fundamental units, displacement, time, distance. But here this is a derived physical quantity, this is a fundamental physical quantity. Now I make all is the fundamental. So displacement means L1 divided by time T1, distance again L1. So this L1 L1 get cancel, you can make this cancel L1 L1. So the result is what? T, it is not written like that, it should be T minus 1 with a square bracket. So this is the dimension. This is the dimension. Clear? So dimension of velocity gradient is what? Minus 1 in time. Minus 1 in a time. Dimension formula is T minus 1. Dimensional equation means velocity gradient is equal to T minus 1. What is the unit? Second minus 1. That is the second minus 1. Okay. Then next we will go for the next physical quantity I will go for. Now go for the momentum. Next is the momentum. Linear momentum. Simply it is called as the linear momentum. Then another part we will discuss about angular momentum. Angular means that is a rotational motion. If I am rotating like this, in a rotating, means that we will get angular momentum. Linear momentum. I am moving in a linear path like this. That is the linear momentum. So when we discuss about linear momentum, means what is this momentum means? The motion contained in a body. The motion contained in a body. If I am running, I have a mass. With my mass, what velocity I am moving, that combined effect is called as momentum. Combined effect is called as a momentum. So, if I ask for linear momentum means this should be mass into velocity. That is the formula. Mass into velocity. As you know the dimension of mass and velocity, if you don't know the velocity, then you go for the again simplified formula. Again simplified formula means I will write mass, make this velocity into fundamental, that is displacement. Displacement by time. Now all are fundamental into velocity or mass into displacement time. So that is the linear momentum. Mass means m1, displacement L1, time means t1. So if you write like this, m1 L1 t minus 1. Okay. What the SI unit? kg 1. No need to write 1. It means kg power is 1. Length meter 1. Time second minus 1. Or you can write 1 1 minus 1. That is a very simple one. Okay. Then we will go for the acceleration. Next one is the acceleration. Now we go for the acceleration. Acceleration. So what is a dimension of this acceleration? Okay. So acceleration is what? This acceleration is change in velocity by time. Change in velocity by time. What is this acceleration means? Acceleration means what is the meaning of this acceleration? So acceleration means change in velocity by time. Take a simple thing that when you are in a bike, you are telling that please accelerate the bike. Means you are changing the velocity of the bike. You are changing the velocity of the bike with time. That is called acceleration. Then you put sudden brake. With what velocity you are moving, the velocity suddenly decreases. When you put the brake, means you are decelerating. Accelerating, or that in that case it is also decelerating. Means changing the, decreasing the velocity. Acceleration means increasing velocity. Change in velocity means it is increasing. Deceleration. 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 Same thing. Acceleration and both are same dimension, but the physical quantity meaning is different. Deceleration means decreasing the velocity. Acceleration means increasing the velocity with time. So when this is the formula is saying changing velocity by time, that's why I written changing. So your acceleration and deceleration both are of the same dimension, same physics. For dimensional, on the basis of dimensional analysis, they are of the same dimension. So that's why I have written in one form. Acceleration and deceleration. Then in that case, what you find? Velocity already know the dimension, L1 t minus 2. Now I will not go for the fundamental. You do when you are watching this video, pause the video and you go for the last section where I have discussed about the velocity part. So I will put directly L1 t minus 1. For time it is t1. But that is not written like this. We write L1 t minus 1. Then this t1 goes to up. So this should be t minus 1. So t minus 1 how much? T minus 2. So I can write this as t minus 2. L1 t minus 2. So that is the dimension of acceleration. What is the unit? Meter second minus 2. That is the unit of acceleration or deceleration. Clear? So this is the dimension of acceleration, L2 t minus 2. Clear? Then next we will go to the acceleration due to gravity. G. That is also the same dimension. Acceleration due to gravity. Acceleration due to gravity. Same dimension. Formula, working formula may be different. When you read about gravitation, the formula is different. But it is involved acceleration means it is the same dimension. No need to go for the formula. The formula you can find it here by using other expressions. But it is acceleration means acceleration due to gravity means what? With what acceleration? If I fall this body is freely falling. If I leave the body from this side, it will fall. If it will fall means its velocity is changing with respect to time, so it is an acceleration. So what that acceleration called? This is attracted by Earth with a force. With what acceleration it is moving? That is called acceleration due to gravity. Earth attracts everybody towards its center or towards its surface. So with what acceleration, if the Earth is attracting, with what acceleration the body is moving towards Earth? That is called as the acceleration due to gravity. So the formula and the dimension is same, L1 T minus 2, and the unit is also same, meter second minus 2. Clear? So this is the acceleration due to gravity. Now I will go for the another one, the force. So all of you know about the force. What is the force? Force means you are pulling or pushing something. Means you are applying force. You are pulling or pushing something. Means you are applying force. Right? And force is a very fast topic. We will discuss in due course of time. But when you are moving or pushing, or when you are pushing or pulling a body, the body is accelerating. If the body is moving slowly and if you push that body, its speed, its velocity increases. Its velocity increases. If a body is moving with a velocity and if you stop the body, then its acceleration decreasing. Means force acting on the body changes its acceleration. Same body, if the same body and the force is acting, it changes its acceleration. The formula for force is mass into acceleration. Mass into acceleration. Already you know the dimension of mass and acceleration. So m1 to the mass, acceleration is what? L1 T minus 2. If you multiply that, don't put this multiply sign. M1, acceleration is L1 T minus 2 with a square bracket. This is the dimension. Right? And to write the SI unit, I can write this as kg meter second minus 2. Kg meter minus 2. And its equivalent can be written as Newton in SI. In CGS, that will be right here. CGS unit is dyne. When you write dyne means what? Kg means it will be kg. In SCGS what kg? Kg will be gram. Meter means centimeter. Second means second. Second is same in CGS. So gram 1, cm 1, second minus 2. That is also called as dyne. And this one is also called as a Newton. This one is called as a dyne. So that is the SI unit of force. And that's the same formula for force, weight, tension, force, weight, tension, right? All are of same thing, right? So force, weight, tension, and another one is also called as the normal reaction. Normal reaction. These are different physical quantities, but the same dimension. Means what? When you are calculating force means mass into acceleration. Weight means what? What is your weight? Weight means with what force the earth is attracting to you. With what force the earth is attracting to you. That is your weight. What is the weight of this pen? Weight of this pen is with what force earth is attracting this body. That is its weight. Okay? So weight means mass of this body into here acceleration is the general acceleration. Here the weight for weight was mass into acceleration due to gravity, because earth is involved. When earth is involved, the acceleration should be replaced by acceleration of earth. With what acceleration the body is moving, that acceleration should be acceleration due to gravity. Then both are same dimension, so both are same. So unit is same, everything is same. Tension. When this is a common simple experiment is that, so this is a body, this is a string. Now you attach a weight at this place. Attach a weight at this place. Means what? If I hold this one with 5 kg, the body will stand. It does not break. This will stand. Means this weight, when you attach this weight, here a force is acting on this side. Means in this side it is attracted. Attracted means it is attracted towards the earth. But in this body there is a tension, oppositional force is there in the body. So that is called as your tension. The opposing force to the weight, that is called as your tension. That is called as your tension. Similarly, if you take a string, the simple thing is that take a string or a rope and you stretch that. Pick that two ends and stretch. Means that what is happening there? It is stretching. Means that tension is acting in the room. That is called tension. Normal reaction. I am standing here. Earth is attracting to me towards its center. So I should go in deep inside the earth. But I am not going there. Why? Because there is an opposition to that way. That is called as your normal reaction. So if this is the body, the weight is here, W, the normal reaction is here, R. R is the normal reaction. Oppose this one. So long as R is equal to W, the body remains as it is. If R and the W is imbalance, the body will do or some acceleration will come to the body. Or the body has some acceleration. So all these have same dimension. Here, next we will go for the another physical quantity. Now we go for the another physical quantity like your coefficient of friction. Coefficient of friction. What is friction? When we are moving on the surface of a body. So the body is moving on this surface. If the body is moving in this direction, the frictional force between this surface and this surface acts in opposite. That is the friction. So the coefficient of friction means what is the formula? So already you know the friction. The soles of our shoe are rough to minimize the friction, to maximize the friction. Because without friction, we will slide. If there is no friction, we will slide. Right? So this is the force of friction by normal reaction. Force of friction formula is force of friction, which is a force by normal reaction. As I already told, both are of same dimension. So force and normal reaction both are of same dimension. M1, L1, P minus 1, that is force. Normal reaction same. M1, L1, P minus 2. So they cancel M0, L0, P0. This is the dimension. Means there is no dimension. If there is no dimension, then you can say no unit. Right? So coefficient of friction. Already you got another physical quantity, that is the specific gravity. It has also no dimension and no reaction. Okay. Then another is the force constant. Now we go for the force constant. Another physical quantity, force constant. Force constant. What is force constant? The force constant is for a spring, this value is calculated. Force constant. Means, if there is a string is there, take the simple example. There is a string is there. The string what is using in your pen, take that string, and you take a string which is in your vehicle. Both the strings are different. Different in the sense is that in the string what is you using in your pen, that string, if you attach a 5 kg weight on that string, then the string will break. But the same 5 kg is attached to the string what is used in your automobiles. If you use that, then in that case, that string will withstand that string. Means it has a larger force constant. It does not break. Means the point is that larger is the force constant of the string, it will give more weight and it cannot break. So that is called as your force constant. So force constant is the how much force you are applied by its extension. How much is the extension? Same thing. So this is the string. If you attach a weight here, you are applying a weight means you are applying a force, it extends. It extends. So if you apply a force, it extends means force is applied, extension is there. So how much force is applied? With what extension? That ratio is called force constant. Extension means you are measuring length. Force is M1, L1, P minus 2. Extension is L1. So this L1, L1 get cancelled. So you will get M1, P minus 2. M1, P minus 2. So what the unit of this one means? So we say kg second minus 2. The unit is kg second minus 2. If you write in other way, equivalent unit, force unit is already know that what? Newton. Extension is meter, Newton per meter. Both are same thing. This is also the unit or this is also the unit. You can say the force constant. Next, the most one is the important one is the wall. Work is what? Work unit. Work. What is that work? We are applying a force and the body is moving along the direction of force. Then we can say that work is said to be done. Here, this is the body. I am applying a force. The body is not moving. No work is done. That is in physics. But I was doing what? A pulley with some weight on his head and standing on the platform. According to our physics concept, the pulley does no work. But if you say that in practically the pulley does no work, then you will be in a problem. But in physics, we can say there is no work. So work is that thing. When I apply a force, the body should displace along the direction of applied force, or the body has a displacement along the direction of applied force. If this is the body, I am applying a force, the body is displacing, moving. Force is applied and the body is moving. Work is said to be done. So that's the work is the force into displacement. Force into displacement. What is force? M1, L1, T minus 2. What is displacement? Again L1. So you write M1, L1 into L1, L2, T minus 2. This is the M1, L2, T minus 2. Okay? So if you put that one, M1, L2, T minus 2, what is the unit here? kg 1 meter 2 second minus 2. Or that is also called as joule in SI. That is equivalent to joule. kg1 meter 2 second minus 2. That we can say that joule. We will read that in later slides. Similarly, another one is the energy. The energy may be kinetic energy. You read about kinetic energy and potential energy. What is kinetic energy and what is potential energy? If I am at rest, what is the energy in my body? That is my potential energy. I am moving. What is the energy in me? I have the kinetic energy. Clear? The potential energy, what is there? According to that, I will get the kinetic energy. If I am moving here, then I will get the kinetic energy. So both the energies are same. Formula is different. Kinetic energy, when you calculate this kinetic energy is equal to, what is that? Half into mass into velocity square. The kinetic energy is half into mass into velocity square. Right? Because it is involved in motion, so it should be velocity square. So here the most important thing is that this is a numerical half. Half has no dimension. Half has no dimension. If there is no dimension, then when you calculate, mass has m1, velocity already what? m1 t minus 1 to the power 2. So if you take the square, then what will you get? m1 L1 into 2, L2, T minus 1 into 2, T minus 2. So this is the dimension. M1, L2, T minus 2. Work and kinetic energy both have the same dimension. Means work and energy have the same dimension. Unit is also same. I will not write this one. kg1, meter 2, second minus 2 or joule. Similarly, another physical quantity, that is your potential energy. If you find the potential energy also, potential energy, that potential energy is equal to mass into acceleration due to gravity. Acceleration due to gravity. Mass into acceleration due to gravity into height. HEIGH. Height. So mass, when you find the dimension, mass is m1, acceleration due to gravity, L1 T minus 2, height, again L1, multiply that into L1. So if you combine all these things, what will you get? M1, L2, L1, L2, T minus 2. It is also the same dimension. So work, kinetic energy, potential energy has the same dimension. So energy, you can say that all total energy has the same dimension. Then I will go for the power. What is that power? How much work is done in a time or unit time? How much work is done for unit time? That is called as your power. You are telling that in common sense. I have more power than you. I am more stronger than you. I have more power. Means in 1 second I can do more work compared to you. Then I have more power. So power is equal to, the formula is, or power is equal to work by time. Work, if you don't know work dimension, then you have to calculate that work. Work equal to force into displacement. Then displacement is a fundamental, but work force is not a fundamental. It is derived. Then force is equal to mass into acceleration. Mass is a fundamental. Then acceleration is a velocity by time. Then velocity is not a fundamental. Then you have to put that displacement by time. Accordingly, you have to calculate. But already you have derived for work and time, so I will put directly for work m1 m2 t minus 2 divided by time is t1. So if you write this one m1 m2 t minus 1, this will go up minus 1 minus 2 minus 1 minus 3. That is the power. So if you write this one kg meter to second minus 3, that is the power, unit of power. Okay. Or this is whenever I am using this as a watt. In practical unit, or this is we are making that concept as a watt. This kg1 meter per second minus 3 also called as a watt. Okay. Then next is the impulse. What is that impulse? Impulse is a physical quantity, a force acting for a small time. That is called impulse. A force, impulse. Impulse is the force acting for a small time. Take a ball, throw to the wall. Means with that wall, the ball is applying some force to the wall for a small interval of time and bounce back. Means when you apply an impulse, then there is an impulse, it changes the momentum of the body. With what velocity I will throw the ball to the wall, it will not come with that same velocity. The velocity changes. Velocity changes means it is momentum changes. Momentum equal to mass into velocity. So accordingly, the impulse is there. So impulse is the what? The impulse is that the formula can be change in momentum. You can say impulse is the change in momentum, or you can say force into time, or you can say the large force acting for a small time. So if you know force is m1 L1 t minus 2 and time is into t1. So m1 L1 t minus 1 minus 2 plus 1. Already got this type of dimension for what? Linear momentum. Means impulse and linear momentum has the same dimension, but the physical quantity are different. Linear momentum is not impulse, they are different physical quantity. That's why in the beginning I told that the two physical quantities may have same dimension. Don't get confused, right? So this is the same dimension. So if you write then kg meter second minus 1, or if from here formula force is Newton, time is second, Newton second. That is your impulse. Okay. Then with that you will find that is then another part is the stress. There is another physical quantity that is called as the stress. For the dimension formula of stress. Stress is what? Stress is a physical quantity, that is the force acting or the force acting in a unit area. Means what? Take a rope, tie one end, keep this one end fixed, and attach a mass here, weight, or apply a force at this end. How much force is applied to this area? It has an area. It has an area. This is the area, cross-sectional area. To this area, how much force applied? That is called stress. And stress is equal to force by area. Stress is equal to force by area. So force is what? M1, L1, P minus 2, area is L2. So L2 goes up, M1, L minus 2 into L1, minus 2 plus 1, L minus 1, P minus 2. That is the stress. If you write the unit, kg meter minus 1, second minus 2. Kg meter minus 1, second minus 2. Or from here you can write Newton by meter square. Newton by meter square. Clear? So this is about the stress. Similarly, for pressure also the same dimension. Pressure is the force or area. Same formula. Pressure is also the same formula, force by area, and it is also the same dimension. Okay. Then another one you remember here, that is the strain. Then another physical quantity that is coming like in the discussion, that is strain. Strain is what? The same example. When I apply a stress, force is applied to the area. The length of this one will increase. It will stretch. Change in length by original length. That is called strain. Or change in area by original area. That is also called strain. Change in configuration by original configuration. The formula is change in configuration. Configuration means dimension. Change in configuration by original configuration. That is called strain. So configuration is change in length by original length. Length by length. So it is always m0, m0, p0. It has no dimension. It has no dimension. Okay. Then another one from the stress and strain. You will read this in your elasticity. There is a chapter that is elasticity. There you will come across this stress and strain. From here, they will get another quantity called as the modulus of elasticity or coefficient of elasticity. Modulus of elasticity, or for example coefficient of elasticity. Coefficient of elasticity. Okay. So what is the formula? Is stress by strain. Stress by strain. So stress dimension already you know that M1. What is stress dimension? M1, L minus 1, T minus 2. That the stress dimension is what? Stress is M1, L minus 1, T minus 2. Different strain is what? M0, L0, T0. So this you can write, it is no dimension, the same is equal to, you can write M1, L minus 1, T minus 2, it is square bracket. And what is that? Unit, kg, meter minus 1, second minus 2. And remember, when you discuss this one, you will get the same thing. In some cases, you will find the Young's modulus of elasticity. Young's modulus of elasticity. You will get this one. Young's modulus of elasticity from this concept. If I ask you what is the dimension of Young's modulus of elasticity, you will say that stress by strain. Formula is there, but the modulus of elasticity has different names for different applications. It has different names in different applications. In one case, it is called Young's modulus of elasticity. It is same as modulus of elasticity, same dimension. Then another one you can say that work modulus of elasticity. Work modulus of elasticity. Here, work modulus of elasticity. It is also the same dimension. Okay. So these are the different dimensions of the different physical quantity. Okay. So next we will go for the another physical quantity is the surface tension. The surface tension is a physical quantity which has a dimension of surface tension. Surface tension is a physical quantity. What is the dimension of this surface tension? Surface tension is what? It is the physical quantity. The surface tension is like your force acting for unit length. Force for length. Students, this concept comes in your fluid mechanics. When you see the water surface, it has a surface tension. Means if you place a heavier object on the surface of water, the water surface looks like a tension acting on the surface. That like the case is like when you place a body, it will press that place. That press will the water surface will looks like this. See here, the water surface looks like this. When you release that body, the surface comes to its original shape. So this is called surface tension of water. So it is the force or length. Force is M1, L1, T minus 2. Length is what? L1. So L1 will get cancelled. M1, T minus 2. That is called as your surface tension. Okay, and the surface tension is, or you can write M1, or if you write this L also, you can write L0 T minus 1, sorry, minus 2, M1 L0 T minus 2. So if you write the unit of the surface tension, what the unit will be? kg per second minus 2. There is no unit of length, kg second minus 2. Or from this one you can also write, or Newton per meter. Clear? This is the surface tension. Then rate of flow. Rate of flow, same fluid. Rate of flow. How much fluid is flowing in a volume? How much is the fluid flowing through a volume? How much water is flowing? That is called rate of flow. So volume, how much volume flowing in a time? That is called how much water is volume in a time? That is called as the rate of flow. So rate of flow in volume is LP and time is T1. That is like LP T minus 1. L3 T minus 1. Okay, and this is equal to meter cube second minus 1. This is the rate of. Okay, so the students, so far we have gone through some of the physical quantities and its dimension. Next, another video will go for some other physical quantities, and I will find the dimension of these physical quantities with a little bit of idea about the physical quantities. But remember, for this time being, you feel some difficulties because you don't know about these physical quantities. But in due course of time, when you read more and more about this physical quantity, you will by heart the formula for this physical quantity. Okay, students, thank you.